Okay, so let's get started. So directions state the requested characteristics. So here we have domain, range, x-intercept, y-intercept, vertex, line of symmetry, max or min, transformations. Okay, so before we even start into the math, believe it or not, the math is the easy part. I want you to understand what domain, range, x, y, all these words mean. I feel before moving forward, we need to know what these things are. So beginning with the domain and the range. Domain is pretty simple. Domain is basically all the possible x values of a function. So this guy. That's pretty much what that is. So it's all the possible x values of a function. So whatever x could possibly be. Nothing crazy, right? Range is basically all the possible values of y in the function. So domain is for the x, range is for the y. In addition, range kind of goes a little bit further than that. Range is also the difference between the greatest and the smallest value. So in short, range is kind of like the statistical measure of depression, right? Highlighting how different the numbers are. So from the biggest side to the smallest side. So, right, if we're doing the y-axis, from up here-ish to down here-ish, a long ways. X, domain, is side to side, while range is up and down. Not too bad, right? Now, x and y intercepts are basically the points where it literally says it in the name. So x-intercept is every time, right here on the x-axis, anything passes it, right? It's like a football person, right? We got a person right here, throws a football to another person, and they're ready to catch it. But then someone comes and intercepts it, right? And doesn't let this person get it. So same thing here. Although the graph continues and continues going this way, it intercepts twice on the x-axis. Likewise, y-intercept is where does it intercept on the y, specifically on this line. So that's a crucial point. Well, how many times does it hit the x and the y? 1, 2 for x, only 1 time for y. So that's the most simplest one. Now, vertex. Vertex can be confusing for some, but I like to think of it of how pointy the little corner is of our graph. Not here, but here. Let me explain. So vertex is the point at the intersection of any two linear constructions, either a line or line segment or a ray. So I hope you know the difference. So this is a line. Oops, let me use a different color. This is a line. This is a line segment because it's a piece of this. So if we were to zoom into that, it would be this thing. So line segment. So we have a line. We have a line segment where it's specifically cut off. Sorry, I made a bump right there. So it's just a straight line with 2 points because it's a segment. It's a piece of a bigger line. And then we obviously have a ray. A ray looks like this. 1 point like that. So this one's a ray. A line segment for short. So the vertex is basically this part right here. It's the pointy part. So like let's say we had a weird graph, something like this, line segment. If we had a graph like this, vertex. You feel me? So that's basically all that is. Now we have line of symmetry. So line of symmetry, do you know what symmetry means? It's just how nice and even something looks. So if we were to pretend this is a mirror, and this is a reflection of that, you would agree that it's pretty much symmetrical. So in mathematics, a reflection of symmetry or line symmetry or even mirror symmetry or mirror image symmetry is a symmetry with respect to a reflection. So as if you're looking in the mirror. So in this figure, which does not change upon undergoing a reflection, has a reflectional symmetry. So it looks pretty much even. Now, it's not being reflected amongst the x-axis. It's being reflected at point 1, 2, 3. Boom. And we just go straight up. At point 3 of the x-axis. So that's just breaking these guys down. This and this we'll see with practice, and I'll explain that later. But that's just kind of like a little quick intro to these. Next, we're going to start actually doing problems.